like how to do this using like what is the formula for this and how to calculate it without any module or anything. So let's say using just simple multiplication, like how to derive this, like we get the result using simple multiplication. Then after this, we have to see what NCR, like I'll show you, NCR can get very big very soon. So these values are very huge. So 99% of the times you don't actually require the just the using the formula. Why? Because NCR values are very big. So now the concept of modulo will come. So if modulo is coming, then this will include binary exponentiation concepts and also modulo properties, like all the modulo properties, including modular division. So all of these things have already been covered, right? So after doing this, once we know like how to get the NCR values, then there is one thing, that is stars and bars. Stars and bars. So this is also very important. In this, there are two things that we cover, but okay, it's like there's no point in writing it down right now. So here I'll also tell you about a template, like if you want like how to use a template, and okay, this is more than enough. So let's dive into this NCR. So first of all, what is NCR? NCR is nothing but if you have NCR is nothing but if you have n objects and you want to pick r objects out of this. So first of all, like this statement is very like absurd. Like the generally NCR is nothing but if you have n objects, then the number of ways you can pick r objects out of these n objects. First of all, now the thing is these n objects should be same. Like if you can like they like probability of picking any of these n objects should be same. By like that what I mean by same, see if you have numbers from 1 to 10, like 1 2 3 4 5 6 7 8 9 and 10, and you are asked like how many ways there are to pick two numbers out of this doesn't mean that 3 and 4 are same. No, they are different. But the thing is, for this problem you can assume that the problem like the chances of picking 3 are same as chances of picking 4, right? Yes, no? So you cannot apply NCR directly on those things if the chances of picking any of these are like different. I'll come to that also, like how like in that case what you can do. But first of all, NCR can only be applied if all the n objects have the equal chances or equal probability of getting chosen, if you're not biased towards any object. So this is really important, then only you can pick. This doesn't mean that the objects need to be literally the same, like 3 and 4 are not same. But what if I was biased towards 3? Then what do you think? Like in those problems, I'll just give you a scenario. In those problems, usually what we do, instead of like if 3 is twice likely to get chosen, like if you have something like this, then instead of taking just 1 time 3, you can take it 2 times. So we are not going to go into this part because first of all, you won't face these kinds of issues like very often, and secondly, this is like really not the motive of today's class. So now it is clear what is NCR. So how to calculate this? So basically the formula for this is n factorial divided by r factorial into n minus r factorial. So like I have a habit of writing factorial like this. You can also write it like this. So but during the class I'll write factorial like this only, right? Okay, because I have a habit of writing it like this. So now if this is the thing, then first of all, can we not calculate this directly using like see what is n factorial? It is nothing but 1 times 2 times 3 all the way up till n minus 1 times n. So we can calculate each of these factorials, then finally divide this thing by this and this, right? Yes, no? And we will always get a integer result, because NCR, number of ways, can never turn out to be decimal. Like how can ways turn out to be like decimal, right? So you won't have floating point numbers. So this thing you can calculate for small values of n and for small values of r. You can actually calculate these values, right? Yes, no, anything?
Yes.
Okay. But now coming to see, you'll have to somehow avoid, like there are two things that you want now, like you can further optimize. The first thing is that you want to calculate NCR of every number like for which n is large. Like n is large, by large I mean n is going up till 10 to the power 6. if first of all, if n is in order of 10 to the power 9 and you are trying to calculate NCR, then first of all, like you need to have it in mind that you're going somewhere wrong. So if you have n going up till like n is more than 10 to the power 9 or equals to 10 to the power, like it is in this order, then NCR is not a valid option. NCR is a valid option if R is something like less than or equals to 4. Like for 4 also it will get very complicated, but for R is equals to 3 or 2, you can calculate it. But again, if n is 10 to the power 9, can anyone tell me what will be the like NC3B? Like it's just what will be the order of it? Like 10 to the power what? If n is 10 to the power 9. What do you think? See, today's class is going to be just maths only. So you'll get bored very soon if you're not actively participating. Yes, it will be in order of something like 10 to the power 27. Why? Because n factorial nc3 is nothing but n into n minus 1 into n minus 2 divided by 3 factorial, which is 3 into 2, which is 6, right? So this thing will be somewhere in order of 10 to the power 27 or 26. So anyways, you cannot store this number in an integer also. You can have modulos or something, then only you can store it. So directly storing this thing is not possible. Then if you have to take modulo, then also if you have to use modulo or something, you'll pretty soon find that if you have to use modulo, you'll somehow have to calculate factorial of n, right? Why? Because we have used factorial of n here. So you'll have to calculate factorial of n using mod. So now, in order to calculate this thing, you'll have to have these at least n operations, a loop running for n. So that's why if you have n in this order, so the first thing that should come to mind is NCR is not a valid approach here. Something if n is up till 10 to the power 6, then only NCR is valid. 10 to the power 6 or maybe sometimes till 10 to the power 7. So coming back to this, if n factorial is this thing, then we have two things that we can optimize. That is, the first one is the complexity. That is, we don't want each time doing this complete, like going iterating through a loop, calculating the numerator, calculating the denominator, and dividing this. We want something better than that. So what we can do, we can actually store all the n factorial values from, let's say, 1 to 10 to the power 6. We can store these values, and we can store for a fixed r, and if let's say n, like for a fixed n, we can just store what is the inverse of let's say, okay, instead of complicating it right away, I will do one thing. First of all, what we can do, we can store, like once we have stored just factorial of these, how will you calculate NCR? Can anyone tell me? Like if I have already stored these values and you are asked to find this thing, now we can come up with an approach of log of something like log of n. Once we do this pre-computation, this is O of n pre-computation. By pre-computation, I mean that you before going through all the test cases or before like having anything done, you just call a loop and like you just call a function and that function calculates all the n factorials. So this is pre-computation part. Make sure that this is pre-computation only. If you have this inside your test, like you have something like while test minus minus, right? While test minus minus. If you do inside this, if you pre-compute inside this, you'll get a TLE, because for each test case, you're calculating, doing all these operations. So this should be outside your while loop. So this is pre-computation. Okay. After this, how can we achieve the answer NCR? First in log of n. Then we'll try to optimize it further. How to do this?
Multiplication using binary exponentials.
Okay. So first, see, I have the n factorial value directly. Now I need to first calculate the value of r factorial into n minus r factorial. Since r is more than or equals to 1, both of these are also calculated. So I'll easily get the result of this. So let's say this is x. Now, since this complete thing is under modulo, I just want the inverse of x under this mod. So x will be nothing but like inverse, like I just want to calculate inverse of x under this under mod. So how to do this? I can just do one thing, that I can find x to the power mod minus 2, right? Yes, no? Mod, like this mod should be a prime number. Yes?
Yes.
I have already explained why this works in the previous class. So now this thing is okay. This will give you NCRN O of log n. Now can someone tell me how to actually, after pre-computation, how to actually get the result in O of 1? Like in constant time. It shouldn't depend on n. Think about it for a moment. Okay, who did this? Who annotated this? Like I can actually see in the once I stop the recording, I'll actually see who annotated this. So I'm really like, please don't annotate. And whoever did this, kindly like remove it. Like, I'm not going to go ahead unless you remove this. Okay, like even if it was a mistake, remove it. I've disabled annotations, but you need to remove this. Okay, anyway, I have removed it and I have stopped. Like now you cannot annotate any further. But anyway, like this shouldn't, like you shouldn't do this. So okay, going back to where we were. So right now somebody has said that we can do it using multiplying and we need log n complexity. So okay, somebody saying we can store inverses as well. So tell me one thing, if you like for each r from 1 to n, you do one thing that you stored in the inverses. So instead, how like instead of removing this O of like earlier, your pre-computation was of O of n. Why it was O of n? This is clear, right? Because we're calculating factorial from 1 to n, and it can be done using a single loop. And our actual query is NCR was O of log n. Now, if you pre-compute all of the inverses also, then what will happen? You will have query in O of 1, but then your pre-computation time will become O of n log n. Is it making sense? Yes, no?
Yes, yes.
Okay, so see, usually the number of queries is same as like close to, this is usually the case that these two are in the same order. So in that case also, the complexity will be close to, like for each query you are having log n or you are having n log n. So in that case also the complexity is nearly same only. Do I need to repeat myself what I have just said?
Yes, I could not catch up.
Okay, so basically one of the methods somebody suggested in the chat was for having a query in O of 1, what we can do, this is not O of n. What we can do, we can have, in order to have this O of 1, what we can do, we can basically, why is it O of log n? It is because we are calculating inverse of that, this thing, r factorial into n minus r factorial. So why not pre-compute this thing also, like store it. But if we do this blindly, and our pre-computation will become n log n instead of O of n, and now the queries will become O of 1. But since number of queries and n are usually in the same order, like 10 to the power maybe 5 or 6, then like the overall complexity of a solution is still the same, right?
Yes.
Okay, so now I want something. Okay, this is a valid approach. This is okay, but now I want my pre-computation to be O of n only, and query should be like close to O. How to do this? Like you know this, believe me. Like I'll tell you, give you the solution, and you'll see, and it like you'll say that okay, like this is nothing. Like this is just like second, maybe third, fourth class maths. Okay, like I'll come to this in a moment, but first tell me, if you just have to calculate NCR once in your solution, what will you do? If you have to calculate NCR once only, and n is maybe up till 10 to the power 6, and r is also very big, and you have to take like use mod, will you do this thing? Will you copy your NCR template, and will you use your template for that if you have to do it just once? No, right?
No.
Because you can calculate factorial and like, okay, I'll come to this all. So first you need to think in this direction only. How to do this? See, what is, if I have inverse of, if I have inverse of, let's say, if I have inverse of, like, what do I need? I need inverse of every factorial of 1 to factorial of n. I want each of these, right? Because if I have each of these, like not actually n, it should be n minus 1. I need factorial of each of these from factorial 1 to factorial of n minus 1. Why do I need this? Because what is going to be in my denominator? See, it is nothing but n factorial divided by r factorial into n minus r factorial. So r is definitely going to be more than or equals to 1. So what is the smallest that this thing can be? r will be more than or equals to 1 and r will be less than n. Because if r is equals to n, in that case, there is just one way to pick everything. And if r is equals to 0, again, there is only just one way to pick nothing, right? So that's why I'm not including those cases when r is 0 or when r is equals to n. Okay? Yes, no? So the lower limit for this thing, this r is like the range is from 1 to n minus 1. And if this is between 1 to n minus 1, again, n minus r will also be between 1 to n minus 1. So both of these are between 1 to n minus 1 only. Is this thing clear? Why n to n minus 1 and why? Why do I have to only do for one between 1 to n minus 1? Is it making sense? Okay. So now tell me one thing. Instead of first multiplying these two and then taking the inverse, can I not do this thing into multiplied by inverse? Like, let's say, can I not do this thing that inverse of factorial of, let's say, r multiplied by inverse of factorial of n minus r? Can I not do this thing? I can do, right? Yes, no?
Yes.
Okay. Now, if I can do this, can I not just like somehow in my pre-computation, along with the n factorials, I need one more thing. In pre-computation, I want one more thing. I want inverse factorial also calculated, inverse of factorial. So how to do this? Now, can you come up with something? How to do this in O of n? See, if I have inverse factorial, how are we actually calculating factorial of x? We can calculate it using factorial of x minus 1, right? Because everything from 1 to x minus 1 is already multiplied in this thing. And we just need to multiply it with x to get factorial of x. We are not every time starting from 1 to calculate x. Like we are not using 1, we are not doing this thing, right? Up till x. We are doing factorial of x minus 1 times x is factorial of x, right? Yes, no? Okay, so same way, can I not write inverse factorial? Inverse factorial of x is nothing but x times inverse factorial of x plus 1. Now you need to digest this thing. Why there's a minus 1 here and why there's a plus 1 here. This is clear to everyone. I need to explain this thing, right? Why is this true?
Yes.
Let's look at n and n minus 1. For inverse, what is inverse of inverse factorial? Okay, where is it? Where is, like, if I have inverse factorial of n, what is this thing under mod? Like this is nothing but 1 divided by 1 into 2 into 3 and up till n. This, like in denominator, I have n factorial, whole thing modulo, right? This is same as this thing, right? Yes, no, anything? So if I multiply both the sides with n minus 1, on the right hand side, won't I get, like, not with n? Okay, here I've written it wrong. It should be x plus 1. So if I divide both the sides with n, if I multiply both the sides with n, what will I get? On the right hand side, let's first write on the right hand side. On the right hand side, that's nothing but 1 divided by 1 into 2 into 3 all the way up till n minus 1 percentage mod. So this is nothing but inverse factorial of n multiplied by n. And this thing we actually know, this thing is inverse factorial of n minus 1, right? Yes, no? So that's why this thing is true. That inverse factorial of x is nothing but x plus 1 multiplied by inverse factorial of x plus 1. Like this, if you write it like this doesn't much, like this doesn't make sense that much. But if you break this down, like what is actually happening, then it makes sense, right? Is it okay? Like, do I need to tell this again? Yes, no, or is it clear?
But
So
how would you
please
use x
tell
plus
me
1
again.
for the formula?
Like I said, okay, what is inverse factorial? Inverse factorial of x. It is nothing but 1 divided by 1 into 2 into 3 up till x percentile mod, right? Now, if you want from this, you can only go to inverse, like you can, using this, you can calculate inverse factorial of x minus 1. So first of all, what is inverse factorial of x minus 1? It is nothing but 1 into 2 into 3 up till x minus 1. So if you want to achieve this from the above one, then you'll have to multiply this one with x, right? So this is also multiplied with x. So this x will get cancelled and you'll have this thing. So this is nothing but inverse factorial of x into x. Is it okay?
Yes, understood.
Is it clear to everyone? Like this thing will, like, I'm telling you right now, why do we need this extra login optimization? Because you will see on code forces, majority of the people who use this login optimization, their solution gets accepted and others get maybe TLE or something on the, your solution will pass on pre-test, but it will actually fail on those system tests. So now how can we use this to get inverse factorials calculated in O of n? See, first, like when we're calculating factorial, we start with factorial of 1 being to 1, and then for every I from 2 to n, we just do factorial of I is nothing but I into factorial of I minus 1, right? So similarly, we'll first find inverse factorial of n. How to do this? Can anyone tell me? For this, we will use the same login approach. It is nothing but inverse factorial of n is nothing but factorial of n to the power mod minus 2. You can do this using binary exponentiation, right? Yes, no, percentage mod.
Yes.
Once this is done, we just have to do, I will start from n minus 1 and I'll go up till 1, and factorial, inverse factorial of, okay, inverse factorial of I will be nothing but, is it clear?
Yes.
And by the way, you don't have to start from n, you can start from n minus 1 also. Like I said, like there will be no case in which you have to find NCN. Like inverse factorial will be required for that case only, right? If you're doing NCN. So NCN is, by the way, is 1 only. So you can start from n minus 1. But if you start from n also, then also it should work. Like there is no harm in starting from n also, but usually we start from n minus 1. So this thing is clear, right?
So after the pre-computation, we can get NCR in O1.
Yes.
Is that right?
Yes. So let me tell you how to do that. So now we have inverse factorial of everything, and also the factorial of everything. So what we wanted NCR. NCR is nothing but, it is n factorial divided by r factorial into n minus r factorial. So we have n factorial calculated as factorial of n. We have inverse of r factorial calculated as inverse factorial of r. So we will multiply these, and we have inverse factorial of n minus r also. So we'll multiply with that also, factorial of n minus r. And finally, we'll have to take the complete thing modulo, right? And we can simply return this. So this is in O of 1. If you have to calculate NCR and O of 1 per query with pre-computation of O of n. Like pre-computation, let me write it completely. Pre-computation time will be something like O of n for calculating these factorials plus log n for calculating the inverse factorial of first time plus n for calculating the inverse factorial for everything. This is nothing but O of n only, right? You can write this as O of n. Is it clear? Like this thing is clear, right? How I wrote this thing.
Yes.
So is this clear to everyone or no? Like in this, I have skipped all those parts in which like I won't be explaining like why I'm writing this again and again, because like if somebody is having a hard time understanding this, like this thing, factorial of n minus 1 to the power mod minus 2%, you'll have to visit the last like classes recording. So in that I've already explained that this, why this is working, and why can we, like if someone is having this doubt that why can I not like divide like the same way like we do in modular multiplication, why cannot do that? So everything, like you cannot, if you're having those doubts, you'll have to visit the previous class. I won't be discussing those things here. Okay, so now this thing, okay, so I'll show you the template first. Like I'll show you the code, because for this I think the code is necessary. And just give me a second. Like you can ask your doubts if you have any doubt in the code also, and I would suggest that you also make one of your templates and like you save it somewhere, because there's no point in writing this again and again during the contest. So this is the NCR function which will return me, like this function is called, but like down here somewhere in my main function, what is happening in my main function void main. So in here, I have some test cases to answer, right? So it will be like int, it will be something like int t, and then there will be like you take these test cases and input, and then you have to answer each of these test cases inside here. So while this t minus minus, you are answering these test cases, right? But make sure that you like call this pre-compute function before everything. So I would suggest you call your pre-compute function here itself. Why? Because if you there are two things that can go wrong. First thing is you forgot to like call this pre-compute function, and it's quite possible like if you don't call this pre-compute function, all of these value will be zero, and you'll keep on debugging why your logic in this, like you won't even have the slightest or the idea, because this is your template, right? You won't have like you won't get any intuition to check this part, but you'll be you'll keep debugging what is going wrong here, and you'll keep on getting zeros. But the main thing is that you didn't call this pre-compute function. Another thing is that if you call this pre-compute function inside your these cases, then you'll have extra 10 to the power 6 operations or 10 to the power 5 operations in each of for each of the test cases. So then you'll definitely get a TLE. So you should, and by the way, instead of having this thing, you can have just complete logic inside of here also. Like that is also one of the ways. But try to have this separate only. So by the way, someone is asking like, okay, you can, this is, I've taken this from GFG only. So you can also find it there. Like just like usually you will find like log n per query, but if you search that like constant time per query, then you'll find this logic. Like for 80 or 85% of the places, people use log n per query. They don't do this optimization. But if you are not able to find it, like tag me in the text channel and I'll provide you the template. So now how, like what is happening in the C, first you have to calculate, like call this pre-compute function, and then inside here you can use the NCR function. So what is happening in this pre-compute function? Let's go to pre-compute. So this pre-compute is just calculating factorial first. So this is how factorials are calculated. This factorial is nothing but it is a array, and this n needs to be like, this will like depend on your problem statement. If n is going up till 2 into 10 to the power 6, then you'll have to take it as 2 into 10 to the power 6. Usually it is max up till 1 into 10 to the power 6 only, but like it will be always less than that. It is very unlikely that your n is more than 10 to the power 6. Now you will do factorial this thing, then you'll calculate it factorials. Like now after this, you'll have to calculate inverse factorial of n minus 1. So how to do this? You call this modular inverse for this thing. Modular inverse is nothing but modular inverse is just like a syntactic sugar. Like it is wrapping this thing. So what is this function returning? Modular inverse, it is returning k, if k is the thing that for which you need modular inverse. So k to the power mod minus 2, taking this as the mod. So this is just power function. This is like these work as like independently. This doesn't have any context or idea. What is it called for? Similarly, this function doesn't have any idea. Like it will calculate modular inverse for any number k. This will calculate power of any number a to the, like this will return you a to the power b mod m. So this doesn't have any idea for which context it was called. So this is how your code should also be, because see, if you have anything wrong in here, how will you know where you need to debug? So you should be pretty sure that there is like this function is working correctly, this function is working correctly, then there is something going wrong in here. Otherwise, if your code is like your states are merging, like you have same things here and here, then you can run into an error. So try to have like a function is doing just one thing. So here it is just taking a to the power b modulo m. So this thing returns here. So here we are just calculating k to the power mod minus 2 percentage mod. So this is nothing but this is mod inverse of k. So that's why this is the function. Here we will get the mod inverse of factorial of n minus 1. Factorials we have already calculated. Now inverse factorial of I is nothing but inverse factorial of I plus 1 going up till and multiplying this with I plus 1, and you need to only go up till, like you can go up till only 1. Finally, for each, you have to take modulo. So once this pre-compute thing happens, first it will happen O of n. You can, how to find your answer, NCR, like this is your n and this is your r. So first of all, if r is more than n, you have to return 0, because how can you choose or select r items out of n if r is more than n? Otherwise, your numerator is this thing. Multiply your numerator with the factorial of y, take modulo, then multiply your numerator with inverse factorial of x minus y, which is n minus r. So this is r, this is n minus r, and take modulo and return this. Finally, you'll get NCR here. Is it clear? Yes, no. You can ask if you have any doubts right now, otherwise we'll proceed further. Is it clear? Like this should be crystal clear. I'm telling you, like if you are right now like specialist or something, if you want to reach 1700, this is one of the most, like if you have to be stable expert, things that you require are binary search, learn how to do binary search, learn basic combinatorics, be confident in number theory. You should know when to use sorting, searching, those things. You are good to be a stable expert. I'm telling you this thing right now. So this should be crystal clear. That's why I've given this so much time. Like we could have taken this thing with number theory also, but at TLE we have this like a different class of combinatorics, because this will be very, very, very often used. And the thing is, store it in your template. Don't rewrite this each and every time. You can like have different function for this also if you want. like have factorial and inverse factorial in two different functions, then like you'll have a little bit like more help. But don't do it like for you have for each like for each I from 1 to n, you're having different functions. So you should isolate your code up to only till like it makes a sense. So don't isolate your code like more than it is required. Okay. So this thing is clear. Now let's okay. This is combinatorics. Now there is one thing in combinatorics that is like very often used, and like see in combinatorics is one of the things that you can get like you can many times expect a problem statement to just calculate NCR. Like for the other, like if you remember from the last class, I told you that there won't be any scenario in which you are directly asked to find a to the power b. Like it's very unlikely. This will be used in some other like the problem statement will be something else, and as a way to solve the problem, you'll be using a to the power b mod m. But combinatorics is one thing in which you can expect that the problem is around this thing only. You have to do this thing only, just this thing for each test case. You had to decide what will be n. You had to find what will be r, and then just do NCR. So I'll show you how, like two of the most occurring problems. So let's cover stars and bars. Like what is this? So everything is clear till this point, right? Everyone, NCR is clear. Okay. So the thing is, the problem is what is stars and bars, will come to it in a moment. But first of all, how to calculate different ways to represent n. Like you're given an n, how many ways are there to represent n as a sum of k non-zero integers? So let me write it again. Like this is like in code force it will be around 1800 or maybe even 1900 rated problem. So the problem is how many ways there are to represent n as a sum of, like you don't have problem with, like last week I took a class with level 2 and I was trying to cover problems which are a bit more difficult than your level right now, but that is essential for learning, right? See, once I discuss the solution for this thing, you'll know that this was a very easy problem, but you don't have a problem with discussing hard problems or like a little more difficult problem than your level right now, right? Like stars and bars is usually like, it is, I would say, like the problems that you will see is usually around 1600 on code forces, but the topic itself is very easy. So it is okay, right? Otherwise I can take easier also.
It is okay.
This works for everyone, right? Like there were people who were complaining in the last in level 2, I think. Like I didn't teach them this thing, but I took a class on number theory problem solving. So here we have to find how many ways there are to represent n as the sum of k non-zero integers. So k is fixed, k non-zero integers. So first, let me give you an example. How many ways there exist to write, let's say 10. Let's say 10. There are 10. 10 is n, and we have to write it, represent it as a using three numbers. So 10 can be written as 1 plus 4 plus 5. We can write 10 as maybe 1 plus 2 plus 7. You get the idea, right? There are many ways to do this, right? How do you think we can solve this problem?
DP?
DP will work in O of n, and you have many queries like this. So if you do for each query, if you do it using DP, first of all, the DP array will be something like n into k, right? So
I
it's not
think we will place the end balls, and out of n minus 1, we have to place k sticks, right? Wherever you want to place. So n minus 1 ck.
okay.
n minus 1 ck minus 1.
Okay, I'll come to this. So some people are saying there's some. Okay, first of all, n minus 1. Why n minus 1?
Because of non-zero.
There are n spaces between. If there are n stars, there are n minus 1 spaces between them.
Okay. Okay. Actually, let me explain first of all what the stars and bars. See, this problem is very simple. See, assume that you have n stars. And if you just say you have some bars, so like this is one bar and this is another bar. So if you have two bars anywhere in between, you have eventually divided a space into three parts, right? And these will be those three numbers. If n was 10, then Here we have 2, here we have 3, and here we have 5. So 2 plus 3 plus 5 is 10. So you can have these two bars in any places, and that is your answer, right? Yes, no?
Yes.
Are you
Yes.
getting my point? So now tell me how to, what should it be? What should it be? Whether it should be n minus 1 ck or n minus 1 ck minus 1. You get the idea, right? It is just simply n minus 1 ck minus 1. That this is the result. Now this is not that hard, right? And you will find this problem in like Microsoft OA. Exactly this problem I'm telling you. And on Code Forces, these problems are like around 1700, 1600 rated, but they are really simple. So for the 90% of the problems which are NCR, you have to calculate just NCR only, but you have to find what should be n here and what should be the r thing here. Now let's cover one more problem. But you get what is bars, and this methodology is stars and bars, or bars and stars. These are the stars. We have to put bars somewhere in between such that the finally your complete thing will be divided in 3 portions. Now tell me one thing. Another problem is that, see, let me copy this thing. I think you'll be able to answer this. So the problem now is, this is okay. Instead of having non-zero, I have sum of non-negative. Now how can we do this? Any idea?
Now it will be n plus 1 ck minus 1,
Why n plus 1 ck minus 1?
because the non-negative means we are including 0 also. So we will place the stick at side by side also. We can place side by side also.
What about others? Okay, by the way, who told me this n plus 1 ck minus 1? You told me this thing, right?
Yes.
So try to work it out for 10 and maybe not 10, 5 and 3. See, is it giving you a right answer? Think about this for a moment. Like, you can answer this, but think about it. How there are n plus 1 spaces? I'm not getting that much. How are you saying that there are n plus 1 spaces? So if you have 10 and 3, how there are 11 spaces? I want to do. Why?
भैया
Yes, yes.
एक बार वो प्रीवियस वाला क्वेश्चन आप समझा दोगे जो ऊपर वाला था.
Like, first of all, like, you should always try to ask the problems when I'm asking you, because see, this breaks the flow. This is like, there are other people also. Like, how many people want me to go to the last problem once again? I'll quickly go to that problem. Okay, till other people are thinking about this problem, let me explain that problem. You, like, people who don't want to this, like, the above problem to be discussed, you can keep focusing on this one. Try, like, I'm telling you, this is wrong. N plus 1 c minus 1. This is wrong. So till then, I'll discuss this thing. Okay, and anyone who didn't get the last problem, you can focus here. So see, the last problem was how many ways there are to represent n as sum of k non-zero integers. So non-zero is, we'll have to take one or more. So 10 can be written as 1 plus 4 plus 5. 10 can be also written as 1 plus 2 plus 7. So we have to count all of these ways. So how to do this? If you use any DP or anything for each query, like, you'll have to answer in, like, there are many queries. You have to answer each query in O of 1. So the methodology to answer this is, see, if you have n stars, let's say these are the stars, or anything, you can consider n balls or n items. You just have to place k minus 1 bars in between. You cannot have a bar here, because then this segment is not having any number of stars. So what we do, we just have k minus 1 bars in between, and these two bars, like in this case there are two bars, those two bars itself divide the complete n stars in three partitions. So those three partitions will give us these three numbers. So it is nothing but n minus 1. Why n minus 1? Because there are n minus 1 gaps, out of which we need to choose k minus 1. Is it clear?
Yes.
Okay, so now tell me, someone came with this solution.
So sir, answer might be n plus k minus 1 c k minus 1.
Okay, why?
We can consider here, now we have to consider zero values also. So we can consider it as n plus k minus 1 boxes. And in the n plus k minus 1 boxes, let's suppose we put n stars and n sticks we have to put in total. So the number of ways to pick out of n plus k minus 1 boxes, we have to pick k minus 1 boxes for sticks.
Like, I didn't get it. Can you please explain again? Like you're talking about some boxes. See, there are n and there should be k non-negative. So we can have zeros also. Okay, this I get. After this,
So suppose there are n. We have to place k sticks, no?
yes.
Sorry,
K,
k sticks, or we have to divide it into k parts.
yes.
Suppose there are n plus k minus 1 boxes,
N plus
and
k minus 1 boxes. Okay.
and n of them are filled with stars,
Okay.
and
Okay.
out
Yes,
of
I get your
and
idea.
maybe any of them, and out of now what we have to do is that out of n plus k minus 1 boxes, we have to choose k minus 1 boxes to place the sticks.
You have to choose k minus 1 boxes to choose the sticks.
Place the sticks in them.
So, like, what is the order? Like, whether between these two stars, okay, there are some stars like this, but in that isn't like which boxes are having stars? Out of n plus k minus 1, n boxes are having stars. So, which boxes are having stars? Wouldn't that affect?
No, it may not affect. If there is no stick in that box, we can just place out directly, and then we can directly choose between two sticks. If there are no stars, we can take it as 0, and if there are stars, we can consider it as one block itself.
Okay, I still didn't get, but like I still didn't get. See, is there anyone who wants to have who also have some approach? Like, I just want to discuss your approach so that like you'll finally know whether you are thinking in the right direction or wrong. Is there anyone? Otherwise, I'll tell you. Like, I think this guy was right, like, but I couldn't get the methodology.
भैया थोड़ा एक अप्रोच है लाइक आई
Yes.
थिंक कि हम n+1 हमारे पास इसमें पोजीशंस होंगी
Okay.
एंड सिंस यहाँ पर हम 2 स्टिक्स को साथ भी प्लेस कर सकते हैं इस बार तो हम
Okay.
तो n+1 टू द पावर k - 1 नहीं होगा मेरे हिसाब से
n plus 1 to the power
k - 1
n
क्योंकि
plus
हमारे
1 to the
पास
power
n plus
k
1
plus 1. Why k plus 1?
k - 1
K minus 1. Why k minus 1?
बिकॉज वी हैव k - 1 स्टिक्स ना
नहीं, k minus 1
बिकॉज
sticks.
स्टिक्स इतने नहीं एक्चुअली k हमको स्पॉट्स में डिवाइड करना है तो हम k - 1 स्टिक्स में रख देंगे
Okay. Okay.
तो क्योंकि हम यहाँ पर एक ही स्पॉट पर बार बार भी रख सकते हैं ना तो इसलिए पावर सोचा मैंने
Can't we do summation like n minus spaces k can go from if k is 5, like it will be from 4, 3, 2, 1. For n minus 1 space, we put first 4, then we add for n minus 1 for 3, then 2, then 1.
For the first one, it is
Like k, we can accept 0 na. So if k is suppose 5, so we can put 4 sticks also, and we
yes.
can put 3 sticks, then 2 sticks, then 1 stick.
All of like, why is this wrong? See, if you are saying 4, like the odd, you are saying if I have 5 sticks, if I want k is 5, then I have to keep 4 sticks, right? So what I'll do, I'll keep 3 sticks, and the other segment will be 0, right? So which will be 0? Like, you have 3 numbers, which will be 0? This part will be 0, this will be 0, this will be 0, this will be 0.
Yeah, okay, got it.
So 1 plus 4 plus 0 is different than 1 plus 0 plus 4. This representation is different. Other than that, what other method was? Like, majority of the methods will be wrong because of this only. Like, you are not taking the order into consideration. If you're randomly also doing this thing also, then also I think you won't get this thing. Yes, no. So basically, you'll have to choose only out of some positions. Is it making sense? Yes.
Actually, I have an approach like हम क्या कर सकते हैं कि हम n objects और k - 1 sticks को arrange कर सकते हैं और फिर उसके बाद k - 1 sticks जो होंगी वो मतलब सेम है तो उनकी रीअरेंजमेंट कर दो और
Yes,
n objects की रीअरेंजमेंट कर दो तो फिर वो फार्मूला कुछ ऐसा सा ही निकल जाता है मतलब उसको c के टर्म में लिखेंगे तो वो कुछ ऐसा फार्मूला आ रहा है
which formula?
Like n plus k minus 1 c n c k minus 1.
Yes, the formula is correct. This thing is okay. Like this, I know, but I couldn't get your methodology. Maybe the methodology is also right.
Like n plus 1 minus n plus k minus 1 factorial. So that is arrangement of n plus k minus 1 things.
Yes.
And then we'll just divide it by k minus 1 factorial. That will be like we are rearranging the sticks. And then n factorial divided by n factorial, that will be like we'll be rearranging the objects.
Yes. So basically, like everyone, I don't think here is aware of dearrangement, but actually this is okay. Like, why is this okay? See, first of all, if we have to in the number of ways to form the sum, and we have a let's say we have a line, and this line is having n plus k minus 1 points. Okay. So now each position can, like, let's take this is what you told, right? If there are n plus k minus 1 boxes, So let's say these are the position or boxes on this line. So each of these, they can either have a star. This is what you told, right? If I can, yes, no, right? And okay, after this, if you have this thing and you want to divide this into k things, so that if you have, let's say, k as 4, if you have this thing, so by default these two places are already 0. Are you getting my point? Yes, no?
Yes.
So this is also that he told, right? That boxes and
How
stars.
they are zero?
How am I?
How they are zero? How they are
Because
always zero?
like I have just increased some boxes and those boxes are empty. You can like, this is what he told me. So I am also like, this is one of the ways to like visualize this.
And what is the value on the star?
Value star is 1. Like there are n total stars. The final sum of this thing is n only, but some of the boxes are empty. Okay, dearrangement is a little different. I'll share it in the the channel section, but dearrangement is a little different topic. How to dearrange. Like dearrangement is a different topic, like a complete different topic. So that is not going to be covered in level 3. I don't think so. Like if you know it, it's okay. But like I can give you a general idea what dearrangement. Dearrangement is nothing but like it's a permutation of elements. So like let's say there is an element of sets in which no element appears in its original position. So this is basically a dearrangement of your permutation. So this is the very definition. So I don't think that this will be covered. But anyway, you get this idea, right? Like if there are these boxes are empty, then if you have partition 1 here and part like these are the bars, then by default this range will be having zeros only. Yes, no. You can look at this by dearrangement also, but that will be like since that is not covered in as of level 3, this is one of the ways that you can imagine this. Other way,
I don't understand how it is still n plus k minus 1 c k minus 1. मतलब इसके बाद वो form कैसा आया?
okay. Why this thing? See, you have, this is making sense, right? You have n stars, right? This is making sense, right? Now
Yes.
you add k empty boxes here, like k empty stars, k hollow stars somewhere. Now how many total spaces do you have in between? N plus, like there's an empty star here also. So how many total positions do you have? Like earlier there were n minus 1 spaces in between, there are n plus k minus 1 spaces in between. Again, out of all of these positions, you just have to choose k minus 1 bars. So let's say this is a bar, this is a bar, and this is a bar. So how many stars are in this? There are 0. How many stars are in this? There are 3. How many stars are in this? There are 2. And how many stars are there? 1. So if n was something like 6, one of the ways to write 6 is as, if you want to write it as like using 4 numbers, so you can write it as 0 plus 3 plus 2 plus 1. Is it clear now? Where is k mentioned in question? Like you'll get queries here, like okay, you should have asked
पहले n minus 1 में k कहाँ से मतलब ऐड हो गया? So हम इसको से ऐड कर रहे हैं.
n what?
n minus 1 ठीक है. मतलब फिर k कहाँ से ऐड हो रहा है? Like for the previous, you said n minus 1 for the earlier problem.
Yes, it was n minus 1. Now it is n plus k minus 1.
So how is the k getting added?
Like you just added k, like there were n stars. Now you added some hollow stars also, because if you have some hollow stars in between, like this partition is having hollow stars. So by default, the value of this partition, like this partition having 0, contributing 0. So this is a 0 because 0 is allowed now. That's why you added k hollow. And how is, like somebody is asking where is k? K is nothing but k is given to you in a query, right? How many ways are there such that the sum of, like how many ways there are to represent n as a sum of k non-negative integers? There was a k here also, and in the last one also there is a k here. So this is k. Is it clear? Yes.
Excuse me,
Yes.
Yes.
Yeah, how you are so sure that you will add only k hollow stars that will solve the problem?
Because see, if you add more than k hollow stars, there is a possibility that you'll have something like this. There is this star, there is this star. If you add more than k hollow stars, there's a possibility like these are those k stars, right? So this partition is indeed having, like if you don't assume these to be hollow, by default it is having more than, like you can have all your bars here only. Is it making sense? Yes, no? Like you can divide this thing into more than k part, like now more than k partitions. If you add, because all of these will be 0, So eventually the sum is going to be n only, but the total number of partitions that you will get will be, because of these, you'll get more like around k, 0 part k minus 1, 0 partitions. One partition you'll get from here, one partition you'll get from here. The sum of these two will get you n, but the total number of partitions now are n k plus 1. If you added more than k hollow stars. Are you getting my point?
This is the contradictory case.
Yes.
So where we should add the k hollow star, there can be multiple cases when where we can add the k hollow stars.
When we
How
add,
we are choosing it. Yeah, like I understood that we have to add k hollow star, but there
yes,
can be different combinations from where to add that k hollow star. Like they can be some can be in between, some can be at the last. How we are choosing them.
like that thing will get eventually get like you'll eventually get compute by these. Like you're not fixing the bars, right? The bars are also not fixed. Anyway, like out of those n plus, like in any way, you can have hollows anywhere and you can have stars anywhere. Out of the final thing will be n plus k, right? Out of these, you just have
Got
to
it,
select
got
n
it,
plus k minus 1. Out of these empty spaces, you just have to choose k minus 1.
got it.
Every possibility, like anywhere they can be, each possibility will give you one answer. There will be a 0 and there will be non-empty partitions. If you add those, you'll get n. But if you had more than if you add more than k, then the partitions that have 0 stars are more than k itself now. So that's exactly k. Is it clear? Yes, no?
Yes.
What about others? Like I know that this is like, if you haven't solved NCR problems earlier, like I think NCR is also covered as part of class 11th. I'm not sure, 11th or 12th. So there you'll find like majority of the problems which you'll find in CP are easier than the problems that are part of JEE syllabus, I think. So there are many difficult problems. Like de-arrangement is also, I think, covered in class 11th or 12th. But anyway, so if you want, you can, I'll share a website that has really good puzzles like this. If you're good at puzzles, like if you're good at solving puzzles, you'll be very like these problems will be very easy. Like the imagining, like how to place these stars, how to place these bars. But anyway, and I'll share I was trying to come up like find a de-arrangement topic. I'll share it and like you can go through it, because anyway, see, if it is not covered as a part of level 4 syllabus, it doesn't mean that you cannot go like cover it. Just like I'll share some resources, you can go through it, raise a query, and probably we can, like if you're stuck somewhere, you can like ask me on a query, and maybe if you want some problems, I'll give you that also. Like I won't give it as a part of daily problems, because that have to be from combinatoric tools only, but I can share other problems and resources from like for de-arrangement. It is also like you won't find that many problems in easy, like if you are going up to 1600 1700, but after that de-arrangement problems will also be there. So de-arrangement, like this thing can be easily proved using de-arrangement, but since de-arrangement itself is not covered, that's why it's like I am giving you some other methodologies. Like this methodology, this guy right now on the call, like he was saying this, right? So I gave this same. Like first, I also was not convinced for this, but it will work. Like I also saw on internet that there are other methods also, but they are quite complicated. And actually mine was also a little complicated. So imagining this is like, you can like all the problems, if you're able to, like if you are able to get the intuition and the right intuition, the problems become very easy. And as far as the proof or the that thing goes, like how to actually like this intuition is okay, but it's quite possible that you might not get the intuition. So how to come up with a formula that it will be n plus k minus 1 c k minus 1. So that thing can be done using de-arrangement. So is it clear? Yes, no?
Yes.
Okay.
Yes.
And by the way, can this also be done using DP? Think about it for a moment. Can this be done using DP? So okay, anyway, like I won't be discussing how to do this, but yes, it can be done also using DP, but I won't be discussing it here because this is not a class for that. But you should think about this also, like how to do this using DP. Okay, this is okay, this is okay. So now, are there any doubts? Because we are almost done.
ये de-arrangement से कैसे होगा, मतलब थोड़ा आइडिया दे सकते हैं
Like,
अगर पता
actually, okay, let's discuss it after the class. Okay,
है?
are there any other doubts? Are there any other doubts? Yes, no, anything?
No.
Okay, so I think like that's it for today. If like and tell me how like what is the problem rating that you expect for daily tasks for combinatorics?
1400 to 16.
Okay, this works for everyone, right? 14 to 16. Okay, I'll give 14 to 16 only. And tomorrow we'll have problem. We'll discuss problems. Okay, let's take one problem right now. Also, I have a problem in my mind. So we'll discuss one problem right now. That part is covered. Theory part is covered. But we'll take a problem right now. And tomorrow there will be problems on complete number theory plus combinatorics. Okay. So let's say the problem is you are given a string. You have a string. You have a string S, and S contains S is having lowercase alphabets and this character. So now you have to remove this character with any remove this character with any lowercase letter such that after doing this the final string S satisfies this thing, that every subsequence of S is like is forming an increasing sequence. How to do this? How will you do this problem? Like, let me give you an example. So for example, you have S as A star star. Wait, let's not take star. Let's say you have D. So you can either do A, B, D, or you can have A, C, D. So there are two ways. Like you can have, instead of this star, you can have B or C. How to do this problem? Any idea?
So if there we can consider two deterministic letters at one time. For example, if we consider A and D and there are n numbers of stars between them, then we can place any numbers from any letters from A to D or A to C. So we have to make partitions as that count of A plus count of B plus count of C is actually equals to number of stars between A to D.
Okay. Anyone other than this? Like, forget about this. If you are able to solve this problem, be able to like nearly solve 70% of the problems on NCR in your level, like up till 1700 I'm these are the actual problems that you'll find. Like these kinds of problems are the problems that you'll find on contests. See, first of all, when is the answer 0? When you have something like if you have a string like this A star star B, is it possible to fill this two places with some characters such that every subsequence will be strictly increasing? Is it possible?
No.
Why is it not possible? You can have a B here, A B B is not increasing. You can have a C here, these two are not forming increasing. Okay, this is okay. Now if you have something like A star star K star star B, is there any way to fill all of these stars such that final substring will be increasing? No, right?
No.
Because the string itself, like if you remove these stars, itself is not increasing. So the first thing that you need to check is check whether the string after removing all these stars is after removing the stars, the star character is strictly increasing. After you do this, then what you need to do, if there are some, like there will be some patches of stars between characters, right? Yes, no. First of all, a string, you can also check if the size of this string, if the size of this string is more than 26, then answer is no, right? Because how can every subsequence, every possible subsequence can be strictly increasing? Yes, no. Is these two things clear? Now the size is less than or equal to 26 and you're having some patches of stars. So just do one thing. How many characters are between A to K? There are 9 characters, right?
9.
So out of these 9 characters, if you choose any 3 characters, the order is fixed. Let's say you selected D, G, and H. So the order is fixed. D will come here, G will come here, H will come here. So you just need to find how many characters you can choose. So the answer is for this part it's 9C3. Is it making sense?
Yes.
Yes, no. How many characters appear between M and K?
One character between K and M.
One character, L. So out of one character, you have to choose 3 characters. So this thing is 0 itself, right? You cannot choose. And for between M and Z,
12.
12. What is
Yes.
it, 11 or 12?
12.
So this thing is the answer for this discrete, because for this thing is 0, so the complete answer is 0. But if you had something like 7 or 8, then this will be your answer. So for each patch, you just have to find what is the number of characters between these two, and find if there are, like, let's say X character between these two. Just find what is XCY. Y is the number of stars between these two. That is the number of ways you can fill this patch. Is it making sense? Yes, no? Is it clear to everyone?
Yes.
Is anyone having any doubt? Otherwise, like, I'll explain this again. Okay. So like these are the these kinds of problems you'll find. So eventually you should target to like think about, and for NCR problems you just have to find what will be the value of n, what will be the value of this r. If you're able to come up with these two, then NCR problems are really simple. So that's it for today. If you are not able to find that template, tag me in text channel, I'll share the code. And other than that, okay, so you need 1400 to 1600 problems. I'll make sure that the problem difficulty is in this range only. And tomorrow, probably at 2 only, we'll have another class, and that will be completely on problem solving only. So we'll cover problems on number theory, we'll cover problems on combinatorics, those stars and bars. So tomorrow, if today something is not clear, like any of those things, tomorrow when we are solving problems, we'll try to prove everything, not just by intuition. Okay. So thanks for joining, and bye bye.
एक कोई दिक्कत आ रही थी, मतलब लाइक मेरा मतलब एक वीक का बैलेंस में जैसे रह गया था, तो फिर अब वो ये कि मैं करता हूँ तो काफ़ी कॉन्सेप्ट याद नहीं आते, फिर करने का मन नहीं करता, और तो नहीं होती कोई प्रॉब्लम। बाकी लाइक नंबर थ्योरी वगैरह तो हो जाते हैं क्योंकि अभी जस्ट पढ़ा है, तो मतलब
Like
उससे कवर कैसे करूँ?
your voice is not like clear. Can you again let me stop?
अब क्लियर है? इज इट क्लियर नाउ?
Like, is this guy audible to everyone? Like, is everybody able to understand, or is it only on my side? Let me stop the recording.